In this session, let us solve a question from CSIR NET December 2024. The question is from the topic particle in a 3D box. So let us recall some of the things. Particle in 3D box. Potential is V is equal to 0 for X in between 0 and A, Y is in between 0 and B, Z is in between 0 and C. And potential is infinity otherwise. So inside the box we have potential equal to 0 and outside we have potential equal to infinity. Now if we put this potential in Schrodinger equation, then we will get a partial differential equation. If we solve this partial differential equation, we will obtain the wave function to be equal to psi is equal to root of 8 divided by ABC times sine nx pi x by A times sine ny pi y divided by B times sine nz pi z divided by C. And energy will be equal to E is equal to pi square h bar square divided by 2m times nx square divided by A square plus ny square divided by B square plus nz square divided by C square. Now there is a special case where A is equal to B is equal to C. In that case, we say that the particle is in cubical box. For such a case, psi is given by 2 divided by A the whole raised to 3 by 2. We are just putting A is equal to B is equal to C here, and we are also putting A here, nothing else. So we will get 2 by A the whole raised to 3 by 2 sine of nx pi x by A times sine ny pi y by A times sine nz pi z divided by A. E will be equal to pi square h bar square divided by 2m. Now since A, B and C are equal, you can take A outside, A square outside. Therefore energy will be E is equal to pi square h bar square upon 2m A square times nx square plus ny square plus nz square. Now what are the possible values of nx, ny and nz? Nx can be 1, 2, 3 etc. Ny can be 1, 2, 3 etc. and nz can also be 1, 2, 3 etc. The ground state energy will be EGS is equal to, ground state is when nx equal to 1, ny equal to 1, nz equal to 1, and in that case we will have ground state energy is equal to 3 pi square h bar square upon 2m A square. There is only one state, that is psi 111 state with energy 3 pi square h bar square upon 2m A square. Now if you find the first excited state, for first excited state we have nx equal to 2, ny is equal to 1, nz is equal to 1. In this case E is equal to pi square h bar square upon 2m A square times 2 square plus 1 square plus 1 square, which is equal to 6 pi square h bar square upon 2m A square. So this is energy corresponding to the state psi 211. Now if you set nx equal to 1, ny equal to 2, nz equal to 1, then also you will get the same energy. So for psi 1 2 1 also we have the same energy 6 pi square h bar square upon 2 m a square. Now if you set nx equal to 1, ny is equal to 1, nz is equal to 2, for that also you will have same energy. So psi 112 also have the same energy 6 pi square h bar square upon 2 m a square. Therefore we say that first excited state, it has a degeneracy of 3 because three different states have same energy 6 pi square h bar square upon 2 m a square. So these were some discussions related to particle in a box. Now let us come back to the question. In this question we are given a particle of mass m. It is in a cubic box of side A. So we are given the potential of cubical box, particle in a cubical box. Now if the particle is in an energy eigenstate with energy E is equal to 7 pi square h bar square upon m a square, a possible wave function is. So you can compare the formula for energy. Energy is equal to pi square h bar square upon 2 m a square times nx square plus ny square plus nz square for a particle in a cubical box. The given energy is 7 pi square h bar square upon m a square, which I can write as 14 by 2. 7 can be written as 14 by 2 pi square h bar square upon m a square. Now compare with this formula, then we will find that 14 is nothing but nx square plus ny square plus nz square. Therefore to get the correct option here, what you can do is, first you have to identify nx, ny, nz values. In the option 1, the nx value is 1, ny value is 1, nz value is 2. Now take squares of it and add. So you will get 1 square plus 1 square plus 2 square, which is 6. We need 14. We need the sum to be 14. Let us check option B. In option B we have nx equal to 1, ny is equal to 3, nz is equal to 1. In this case, when we square and add, we will get 1 square plus 3 square plus 1 square, which is 11, which is also incorrect. Let us check option 3. In option 3 we have nx equal to 1, ny is equal to 2, nz is equal to 3. Square and add, 1 square plus 2 square plus 3 square is equal to 14. So we are getting 14 when we are squaring and adding nx, ny and nz in option 3. Therefore the option 3 is the correct answer here.